In the previous chapter, we saw how to differentiate many types of functions. In this video, we will talk about how to use derivatives to find tangents and normals to the curves. If we are given f of x is equal to x squared, we know that any slope of a given point is derivative of a function. So we have f prime of x is equal to 2x. This represents a gradient function at any given point. So for example, if x was 2, then we know f prime at 2 would be at 4. This would be a slope of a tangent line at x equals to 2. If we want to talk about the gradient of the normal to the curve, which just means it's perpendicular to the tangent line. So given that slope is 4, how do we find something that is perpendicular to slope 4? We just take the negative reciprocal. Therefore, if we let this to be a slope of a tangent, then slope of a normal, which means just perpendicular, would be negative reciprocal of that number. So then let's talk about the equation of a tangent line and equation of a normal line. When x is equal to 2, we know it passes the graph at 4. Just plug in 2 here, we get 4. So if we were to graph this, x and y axes, and then it's passing through the origin, so something like that, and it passes at 2 and 4. So 1, 2, 1, 2, 3, 4. So it passes through that point. If we want to find a tangent line to the curve, right? This would be a tangent line. We already know that slope is 4 and it must pass through a point 2 and 4. So using that slope we found earlier, we have y is equal to mx plus b, where we know the slope, which is 4. We know the x, which is 2, plus b, and y, that's 4. So we would have 4 is equal to 8 plus b, and therefore b must be negative 4. So equation of a tangent line would be y is equal to 4x minus 4. So that's the equation of this tangent line. If we're talking about a normal line, which we already have said that slope of a normal is equal to negative 1/4. So at 2 and 4 on this point, it has a slope of negative 1/4. So in order to find the equation of a normal line, we have y is equal to negative 1/4 x plus b. Again, we know it must pass through 2 and 4. So 4 is equal to negative 1/4 times 2 plus b. This simplifies into negative half. So in order to solve for b, we need to add half. So it'll be 4.5, or you could also say 9/2 is equal to b. So equation of a normal would be negative 1/4 x plus 4.5. In this video, we'll do something very similar to what we just did. And find the equation of the tangent to f of x equal to x squared plus 1 at the point where x is equal to 1. So graphically representing this, we have the x and y axes, and we have x squared, so it's concaved up, and y-intercept is at 1. Right, so at that point it's going to be equal to 1. When x is equal to 1, right, we have this point at 2. So when x is equal to 1, your y value is going to be at 2. What we are interested in finding, again, is the tangent line at this point. A line that passes through that blue, not as accurate, but you get the idea. So how do we find the equation of this blue line? We know that slope at any given point on f of x function is the same thing as the derivative of a function, which is equal to 2x. So when x is equal to 1, our slope is going to be 2. Right, so that slope of a blue line is 2, and we know it passes through 1 and 2. So given y is equal to mx plus b, where we know y is equal to 2, m is equal to 2 from here, and then x is equal to 1 plus b, which leaves us with the b equals to 0. So the slope of this equation is just y equals to 2x. Alright, next, find the equation of the normal to y equals to 8 over square root of x at the point where x is equal to 4. So we need to find out when x is equal to 4, what's the y value? When x is equal to 4, y value will be 8 over square root of 4. Square root of 4 is just 2, so 8 over 2 is just 4 again. Here we need to find the equation of the normal, so we're first going to find the slope of a tangent line and then take the negative reciprocal to find the slope of a normal. So first, let's rewrite this in non-fractional form. So we have y is equal to 8x raised to the negative half power. So derivative of y would be bring down the negative half in front of the 8. So we have negative 4x. Negative half minus 1 would make it negative 3 over 2. Then we need to plug in for when x is equal to 4. So negative 4 times 4 raise it to the negative 3 over 2. Right. This math looks a little bit complicated, but it's really not. 4 raised to the negative 3 over 2 is same thing as 1 over square root of, that's where that half is coming from, 4 raised to the third power, which is simply 1 over 4 root 4. So if I multiply that with negative 4, I would get negative 4 times 1 over 4 root 4. Cancel it out. We're left with negative 1 over root 4, which is the same thing as negative 1 over 2. So all that work just found us the slope of a tangent line, but we need a slope of a normal. So just take the negative reciprocal of that. Slope of a normal would just be 2. So once we have that, we know now it's really easy wrote from here, 2x plus b, and we know when y is 4 and x is 4, we're trying to figure out the b. So this is 8, so subtract the 8 on both sides, negative 4 is equal to b. Therefore, the equation of the normal would be y is equal to 2x minus 4. So now let's find the equation of any horizontal tangent to y is equal to x cubed minus 12x plus 2. I've used my graphing calculator to graph this function, and we're talking about a horizontal tangent. Horizontal tangents are the lines that runs left to right. So tangent lines exist on this graph at local maximum here and local minimum over here. You could simply use your graphing calculator to find out the y values on each of the local minimum and maximum. That's going to give us the equation of the horizontal tangent lines, and we could also find this mathematically. Well, let's think about the slope on these two lines. What is the slope of a horizontal line? Yes, obviously it's 0. So we know that slope of a horizontal line is 0. In other words, y prime is 0 on these two picked lines. So given y is equal to x cubed minus 12x plus 2, we can take the derivative of this function, which gives us 3x squared minus 12, and set it equal to 0. That's going to give us the slope of 0. Slope at any given line must be 0. So this is just an algebra now. We can factor out the 3 because they have 3 in common. So you're left with minus 4 equals to 0, and then this nicely factors out again to x plus 2 and x minus 2. Therefore, when x is negative 2 and x is 2, I'm going to have a slope of 0. That's this point right here. This is negative 2 and that's positive 2. But I need to know when x is negative 2, right? What's the y value? Y value would be just plug in it to the original function, right? That's going to give us the y value. Plug in y prime is going to give me y prime. I need a y value at x equal to negative 2. So negative 2 to the 8th, that's negative 8, minus 12 times negative 2 will make it a positive 24, plus 2, and that's going to be 18. Alright, so when y is equal to positive 2, this time 2 to the 3rd, that's positive 8, minus 24, plus 2, right? That's going to give us negative 16 minus 2, or add 2, so it's going to be negative 14. So when y is equal to 18, that's going to give me this horizontal tangent. When y is equal to negative 14, that's going to give us this horizontal tangent. Show that the equation of the tangent to y is equal